We have two rectangular sheet of paper M and N of dimension 6 centimeter into 1 centimeter each. So the length and breadth are 6 centimeter, 1 centimeter. Among the sheet M and N, M is rolled to form an open cylinder. Okay, it will be only open cylinder because we have a rectangle sheet. So if I roll, obviously it will be open cylinder. And sheet N is the other one. It's cut into equal square patches. We have another rectangle sheet N, and that is cut into equal square patches, and it is assembled to form the largest possible closed cube, assuming the ends of the cylinders are closed. This is actually open because it is open cylinder because it is formed by rolling the rectangle sheet. Assuming to be a closed cylinder, I mean both the upper face and lower face of the cylinder to be closed, then we have to find the corresponding cylinder volume ratio of cylinder and that of cube. Okay, so I have drawn the corresponding sketches of the question. This is a rectangle having length 6 centimeter and breadth 1 centimeter, and it is named as M and N. Both are of same rectangle and the same dimension. And the one is I mean M is converted to form into cylinder, while N is divided into equal patches to form largest cube. So cylinder is simple because if you roll from this part, you can see this. If I'm rolling about this point, okay, if I roll along this, you can see it would be something like this. Okay, and this 1 centimeter height will be the height of the cylinder. I mean, this 1 centimeter breadth of the rectangle would be the height of the cylinder. You all know that. But in the case of cube, they have mentioned that the cube is formed by equal patches of area from this rectangle. So, the, to not to get the largest possible area, you can see this. If I take one, so there should be 6 patches, equal patches formed from this, not to form this cube, right? So one patch would have an area of 1 centimeter square. So this is whole rectangle would be having an area of 6 centimeter square. So this 1 centimeter square patches of 6 uh, number of patches had to be combined in order to get the total area sum equal, right? So the only possible way to get the maximum possible, I can take the value more than 1 because the total area of the rectangle is 6 centimeter square. If I suppose I take 1 or 2, it won't add up the total area. So maximum possible area would be the supply logically it will be 1. So 1 centimeter square of equal patch, there is total 6 number. So it will be equal to the total area of this rectangle. So that we have a cube of each side 1 centimeter and cylinder of height 1 centimeter, which we can apply logically. Obviously, this roll from this end, so this height would be the height of the cylinder, but we don't have the radius of cylinder. But it can be, if you look, if I'm rotating, rolling about this point, this length would be the circumference. That's why I've written here that the length would be 6 centimeter would be the circumference of the this circular part, right? This top and bottom will be circular in shape. So the circumference of the top and bottom end of the cylinder will be this length of the rectangle. So from that, the radius of cylinder will be around 3 by pi. So we have the equation of cylinder, that is pi r square h, and volume of cube uh, as a cube, where h is 1, we already know, and r is 3 by pi. Okay, it is 3 by pi. So substituting that, and this a is 1. Okay, we have cube of unit length. So substituting that, the answer will be 9 by pi. Okay, just apply the logic in the case of making this cube and finding the radius of the cylinder. Okay.